Hello everyone. Last week we explored k-means clustering and briefly touched upon TSNA as dimensionality reduction technique. And today let's delve deeper into the concept of dimensionality reduction and specifically focus on PCA, which is principal component analysis. First, basically, let's understand what is dimensionality reduction. Dimensionality reduction is the process of simplifying complex datasets by reducing the number of features while retaining essential information. It helps us address the curse of dimensionality, where an excessive number of features can lead to overfitting and noisy models. And what is the working principle of PCA? PCA is a widely used linear dimensionality reduction technique. Its primary goal is to transform a high dimensional dataset into a lower dimensional representation while preserving most of its variance. First, in order to implement PCA, we have to start with standardization, where we start by standardizing the features of our dataset, like standardizing the mean or standard deviation, where mean should be to 0 and standard deviation to 1, so that this ensures that each feature contributes equally to the composition of principal components. Then we try to compute the covariance matrix of the standardized dataset. The covariance matrix summarizes relationship between the features and their variances. After that, we try to perform eigenvalue decomposition on our covariance matrix. This yields eigenvalues and eigenvectors, which are the principal components. Then, principal component selection is done, where we select the top k eigenvectors corresponding to the largest eigenvalues. These eigenvectors form the principal components. They capture most of the variance of the data. And finally, we project the original data onto the selected principal components. This will result us with the lower dimensional representation. Why are we using PCA? Because as I have mentioned earlier, the curse of dimensionality, which means that the larger feature spaces can lead to overfitting, and PCA reduces dimensions while retaining critical information. And also, PCA captures variance using fewer dimensions. So we aim to retain as much variance as possible. Now, since we understood what is PCA and how that works, let us implement it in Python. This is the implementation of PCA on MNIST dataset. First, we have to import all the necessary packages and then load the dataset from sklearn datasets. Then convert the dataset into the pandas data frame. From there, we have to remove columns with zero variance and then uh, convert the dataset into a subset and also normalize the pixel values. Then in the PCA method, we have to first standardize the data, that is, uh, standardize the mean and variance, and then compute the covariance matrix. And from covariance matrix, we have to do the eigenvalue decomposition. from which we get our eigenvalues and eigenvectors. And from here, we have to get top k eigenvectors. And these vectors are projected into data and returned. And here in the data, while calling the PCA method, we have to describe how many components are, into how many components we want to decompose it. And since here I'm passing two components, it will be decomposed into two components. And this is the final visualization of the MNIST dataset after implementing PCA for two components. And in the conclusion, we can now know that PCA is a valuable tool for simplifying complex datasets and improving the model performance for gaining valuable insights. Thank you.